All right. Good morning, everybody. Happy Thursday. Happy Math Day. For those seeing this, most of you know who I am. I'm Mr. Y. If I'm not your calculus teacher, I am the other teacher here at Rochester Prep that also teaches calculus. So today I'm quickly just going to go through some of the questions that you've been working on this morning. I want you to pay really special attention because you might see questions that look a lot like this. Hint, hint. So just take a look, watch how I go through these. Anything you don't have, go ahead and just make sure you're writing as I'm writing. If you need your proctor to pause the video, just go ahead, raise your hand, and let them know. But let's jump into this. So, on number one, if we are taking a look at this function and we want to find the domain, remember that we are actually asking ourselves here we go, for the domain, is, okay, where does this function break, right? Because that's what we want to look at. And so we have this wonderful rational function right here. And we know that with rational functions, and I mean, really with anything, anytime we divide by 0, that's normally our breaking point, right? Because we know that this is undefined. And so, because we know that this is undefined, when we're looking for the domain, right, we're looking for what's actually going to restrict this function. And so we're going to take a look and see, okay, well, when does my denominator, x minus 2, equal to 0? Well, quickly adding 2 to both sides, we're going to learn that, well, hey, this is going to break when x equals 2, which means that we can have everything but x equals 2. Okay, awesome. And so now let's take a look back at this lovely bold statement, right? Write your answer in interval notation and show your work. We showed our work. But the other piece we need to key into is interval notation. Okay, if your answer is not in interval notation, let's think about, okay, are we going to get full credit for this? And so interval notation, remember, that just means, well, my domain, what's just going to be negative infinity to 2 union 2 to infinity, right? And remember that we put parentheses on both those because we obviously can't be defined at negative infinity because that's just not how infinity works. And then per our discovery right here, we also cannot be defined at 2, so we just make sure we put parentheses on both. Okay, if we take a look here now at part B, we're just looking to label the x and y intercepts of this function, and we need to be sure to label each coordinate point. Now, if we're labeling each coordinate point, hopefully it's tracking for us, so that means that our answers have to be coordinate points. And so let's start with the x-intercept. Remember that for the x-intercept, we're simply setting our y to 0. And so we're going to say, okay, well then 0 is equal to 3x plus 1 over x minus 2. When we have a rational function set to 0, we can always start just by multiplying the denominator. It's going to cancel. And on our left, we're still technically going to multiply the denominator, but we're multiplying it by 0. And so it's just going to stay as 0. And so really we're looking at 0 is equal to 3x plus 1. Well, let's subtract 1. Negative 1 is equal to 3x. Divide by 3 to learn that x is equal to negative 1/3. All right. Well, as we just stated, we are not done, right? We need to have a coordinate point. I cannot make this any more clear, right? It's in bold, it's underlined, we got some arrows. And so our x-intercept is going to be negative 1/3, comma, 0. There it is. And so now let's take a look at our y-intercept. Now our y-intercept, a little bit less room, but it's okay. It's a little bit faster. For a y-intercept, remember that instead of setting y to 0, we're setting x to 0. And so we're simply saying, okay, we're going to have f of x, right, or y, is going to be equal to 3 times 0 plus 1 over 0 minus 2. Okay, that means that this y value here, right, is going to be, well, 1 over negative 2. So negative 1/2. Again, not done. Need to make sure it's in a coordinate point. And so our y-intercept here is going to be 0, comma, negative 1/2. And there it is. Again, I'm just going to keep going. If at any point you need this paused, raise your hand and tell your proctor. So now we're looking to find the inverse function of x, and we need to make sure that we're labeling this as f inverse of x. Okay, if we get and we have an answer that says y equals something, doesn't matter how correct of an inverse that's going to be. If we haven't labeled it as f inverse of x, we're not getting that point. So let's take a look at this original function, right? We have 3x plus 1 over x minus 2. And so if I have f of x, right, just simply restating what the original function is, I know that if I'm finding the inverse, step 1 is always just swap the variables. And so I'm going to have x is equal to 3y plus 1 over y minus 2. Now, when we have a denominator like this, and specifically y is our denominator, we need to multiply by our denominator. We have to cancel on our right, and we're going to end up having to distribute this x in on our left. And so what I'm really going to have is yx minus 2x is equal to 3y plus 1. From here, just like algebra, I'm just looking to isolate y, and so I'm going to start moving some things around, adding 2x to both sides. Yx is equal to 3y plus 2x plus 1. Now I'm going to subtract 3y from both sides. I'm going to go ahead and put this right up here. And so I'm going to have yx minus 3y is equal to 2x plus 1. And now that I have my y's on my left-hand side, I'm going to actually factor this out using y as my greatest common factor. And so I'm going to have y times x minus 3 is equal to 2x plus 1. And the reason I do that is because now I can divide by this whole term, right? This whole x minus 3 term on both sides. On the left, well, this is going to cancel. And what we're going to be left with is y is equal to 2x plus 1 over x minus 3. And it looks like we're done. But remember, right, we still have this lovely piece. Again, these are in bold for a reason. We need to make sure that we are fully answering this question. And so now that I have y equals, I'm actually just going to rewrite that as the f inverse of x. And so I'm going to have f inverse of x is going to be equal to 2x plus 1 over x minus 3. And that is our finished answer. All right, moving on. So number 2, we are changing it up slightly, and we're now using the area of a sector. And so right away, first thing we're going to do is we're going to name area of a sector is going to be equal to 1/2 theta r squared. The only thing we have to remember, right, is that this is true where theta is in radians, right? And so if you look, we have a degree value. We cannot use this degree value as it stands. We need to change this. And so luckily it's an easy degree value, right? It's 30 degrees. 30 degrees we know is the same thing as pi over 6. And so now we simply just take our values and plug them in. My area I know is 40 feet squared specifically. And so I know that 40 is going to be equal to 1/2 times pi over 6 times r squared. I don't know what r is. It's in fact what I'm trying to find. And so I'm looking for, okay, r equals what? And so I'm writing it out like this just so I can easily see what's going on and know that I'm going to be canceling some things. First thing I'm going to do, just multiply everything by 2. That's going to cancel with the 1/2. Remember, I got to do it on the other side. 80 is going to be equal to pi over 6 times r squared. From here, I'm going to multiply by the inverse of my fraction. So I'm going to multiply by 6 over pi on both sides. Cancels. Beautiful. On the left, I'm going to have 480 over pi is equal to r squared. From here, well, the only way to undo a square is to take the square root. So I'm going to take the square root of both sides and learn that r is equal to 480 over pi squared underneath our lovely radical. Now, take a look, right? Because up here it says leave your answer as a fraction and or radical. I don't have to go any further than this. In fact, I shouldn't go any further than this. Leave your answer, again, if you happen to see one like this, just like this. All right, taking a look and moving down. Now, in number 3, we need to read carefully. And I'm saying that because there's a lot of pieces in here that we want to make sure we are being really specific about. And so we know that a rare species of ant was discovered in a rainforest in Brazil. Awesome. The population of the ant after T months, okay, right away, T months. T is in months. This is going to be very important shortly. Is given by the equation, all this. What was the population when T equals 0? Label your answer using function notation. Now, remember that using function notation simply means that we are like including this P of T. And so what it means for A is that, well, we're looking for P of 0, which means that we are just substituting in 0 anywhere we see a T. So we're going to have 25 times 1 plus 0.8 times 0 over 2 plus 0.04 times 0. Those lovely decimals are going to go away. And so what I really have is 25 times 1/2. And so P of 0 is going to equal 12.5. That's going to be our answer. We have function notation, right? That function notation is going to be right there. It's that P of 0. And so moving on to question B. Now, this is where that earlier note becomes really important because we're being asked what will the population, or what will be the population after 5 years. Now, take a look. T is in months, right? But we're given years. And so we cannot use 5 as our T value. And so as a result, we need to remember, okay, well, I need months. And so I'm going to take this 5, multiply it by 12, and learn that we should be using 60, right? And so T is actually 60. And so from here, we would go ahead and just plug this in. P of 60. Again, using function notation. Again, you're going to notice that it's here and present in each of these, so we need to be using it for each of these. And we also need to round to the nearest whole number. So P of 60 is going to be equal to, and again, just substituting 60 anywhere we see a T. 25 times 1 plus 0.8 times 60 over 2 plus 0.04 times 60. Which is going to give us 25 times 49, that is a 49, over 4.4. Again, if you're seeing these calculations going, oh my gosh, don't worry, this will most likely be on your calculator portion of your exam. Again, hint, hint. And so once we have this, we're simply going to multiply it out. Let's see what we got. We have 25 times 49 for 1,225. We're going to divide that by 4.4 to learn that our population is going to be 278.4, but we need to round to the nearest whole number here. So we're going to have that P of 60 is going to be equal to 278. Again, making sure we are using this function notation. Lastly, on part C, we want to know when is the population going to be equal to 100. Well, that's simply just swapping our pieces here. And so we're going to have 100 is going to be equal to 25 times 1 plus 0.8t over 2 plus 0.04t. And now we're just solving for t. I'm going to divide both sides by 25. Learn that 4 is equal to 1 plus 0.8t over 2 plus 0.04t. Multiply by my denominator, right? We're going to multiply by 2 plus 0.04t on both sides. I'm going to get 8 plus 0.16t is going to be equal to 1 plus 0.8t. For the sake of time, I am just sort of quickly going through this. From here, again, solving for t. Yes, we have decimals, but it's still just algebra. Subtract 1. 7 plus 0.16t is equal to 0.8t. Subtract 0.16t from both sides. Bring this up here. Now learn that 7 is equal to 4t, divide by 0.64. To learn that t is equal to, let's pull our calculator back up, 7 divided by 0.64. Now, notice that it doesn't say round or anything, so we're just going to go out to 2 decimal points when in doubt. So we're going to have 10.94 months. That's when the population is going to be at 100. All right. Switching gears ever so slightly one more time, we have some trig questions. So we see that this fire tower is 80 meters high. Support wires attached to the tower 20 meters from the top. Now, remember that with trig questions, our setup is crucial. And so drawing a diagram is not only going to get you points, but also going to be how you set yourself up for success. And so I have, right, let's say we have this lovely fire tower, boom, boom, there it is. This entire piece here, as we've been told, it's 80 meters high. We have a support wire attached 20 meters from the top. And so I know that, let's say like right here, right? Let's say that it's attached right here. It's also going to the ground, and it creates an angle of 65 degrees. Okay. So this is going to the ground, creating an angle, right angle there. This is 65 degrees. Now, this is 20, right? It's 20 meters from the top, which means that the actual side length of this triangle is this lovely 80 minus 20, right? Gives us a 60 meters. And so this side length is actually 60. And so now we want to know, okay, well, how long is this wire? Well, we're going to label that wire X. And so let's remind ourselves, right? We have these lovely trig functions, and we have this lovely device that we remember them by. We have SO, CA, TOA. I have, if this is my theta angle, right? This angle right down here, this is my 65, that's my reference angle. I have the line directly across from it, which means, or the side rather, which means that I have my opposite, and then I have my hypotenuse, right? Directly across from my right angle, that's my hypotenuse. And so I need to know, okay, what trig function uses opposite and hypotenuse? So let's take a look. Well, look at that. That's so, right? OH, boom, there it is. Which means I need to be using sine. And so what this means is that the sine of 65 degrees is going to be equal to opposite, which is 60, over x. Now, just a matter of, again, solving for x, right? We've broken down the trig, and now we're really only left with algebra with the trig function. And so I'm going to multiply both sides by x, get that to cancel out because I want it out of my denominator. And so I'm going to have x times the sine of 65 degrees is equal to 60. Now I'm leaving this degree sign because one of the other things we need to be really careful of and make sure that we're doing is making sure that our calculator is in degree mode when we are using degrees. So always double check that before you start. And then from here, divide both sides by the sine of 65 degrees. To learn that x is going to be equal to 60 over the sine of 65 degrees. Again, we can put that right in our calculator. Let's move to our scientific. And so we're going to have 60 divided by the sine of 65, which equals 66.2. Remember, we want this rounded to the nearest tenth according to this question. So 66.2 x equals 66.2. And let's double check our units. Meters. Again, ways to get easy points, include your units. Way to lose easy points, don't include your units. So remember, 66.2 meters. All right. And now we're going to look at number 5. Now, number 5 is another trig question. And again, as I mentioned, setup to trig questions is so important. And so we're going to draw in our rectangle, right? We know we have a short side, and we know we've got a long side. Specifically 2 of each, right? Ooh, a little wonky there. That's okay. So the long side, 30 centimeters, short side, 10 centimeters. And so then we have this lovely diagonal. Now, one of the things we need to be careful of is how this angle is being formed, right? We need the angle formed by the short side and the diagonal. And so what I'm looking for, if I draw in this diagonal, is the short side and the diagonal. So specifically, I'm looking for this. I do not want this. No, don't want that. If it's touching the long side, that is not what we want. We need this on the short side. And so this is my theta. And so now, if this is my angle, well, that means that the 10 is my adjacent, and that the 30 is going to be my opposite. Would that be my right angle? And so, remembering that lovely mnemonic device, right? So, ka, choa. If you need to write it down, write it down. I have opposite and adjacent. The only one that uses both of those, toa, which means I am using tangent, which means that in order to set this up, I'm going to have the tangent of theta is going to be equal to the opposite, 30, over the adjacent, 10. Now, when I'm looking for theta, something we need to remember is that I need to use my inverse function, right? And so on your calculators, you're just going to be hitting second and then the actual trig function, so you'll hit second tan. But what we're going to end up having is that theta is going to be the inverse tangent, right, tan to the negative 1, of 30 over 10. And so now we just plug this in on the calculator. If we go over here, I'm going to have 30 divided by 10. That's 3. Awesome. And now I want... I was going to say the inverse tangent, but apparently mine doesn't want to do that. Let's check the graphing calculator. Well, that's not what we want either. All right, so go ahead and put that in your calculator. See what you're going to get. Your proctors will have the answer, and they will be able to shout it out here. All right. And so, last thing we want to do, because we've gone through all the problems, but we want to remember a few things, right? And so as we've kind of talked about, I know some in my classes, and it's been on some of your packets, is that the biggest part of this test coming up is trig. And so something we want to remember, right, is this lovely unit circle diagram. I'm going to draw what's probably going to be a very crude version of this. And I'm going to tell you right now that I highly recommend you draw this with me and then draw it right away somewhere in your test booklet so that you can refer back to it. And so we have, right, this lovely, really not circle looking piece. We got 4 points. And we have really special coordinates for these points. So we have 0, 1. Oh, I take that back. 1, 0, apologies. This is 0, 1. Negative 1, 0. And 0, negative 1. Anytime we think about this, we always want to remind ourselves that an x and y coordinate on a unit circle is a sine, comma, cosine value, okay? And so we also want to remember we have 0 or 2 pi, same thing as 0 and 360. We have 90 or pi over 2. We have 180 or pi. Then we have 270 or 3 pi over 2. And the other piece that we want to make sure that we're putting in is reference angles, right? Quickly reviewing, how do we find reference angles? Well, in the first one, well, we know how to find reference angles, right? They just are the angles. In the second quadrant, when we are looking for, reference angles, we're taking 180 degrees and subtracting whatever our theta is. So yes, that means that we're going to have to make sure theta is in degrees. That's going to be how. In the third quadrant, we're going to have theta minus 180 degrees. And in our fourth quadrant, we have 360 degrees, again, minus our theta. So anything in a box right now is going to be how we find our reference angles per each quadrant. And then we're also just going to remind ourselves that all students take calculus, right? And that's telling us what's positive in each of these quadrants. We have everything, sine, tangent, and cosine. And so again, I would highly recommend we put some form of this, maybe a neater version of this in our testing booklet as you start so that you have it with you. But at least just seeing it now is going to be a good start. Now, shortly you're going to be starting your test. You have all prepared for this. You have been doing this every day you've been here. Every day that you've taken calc, you have been practicing the skills and going over everything you need to be successful. Okay? It's going to be A, all right, and B, it's a short test, right? Only 2 hours. Nothing too bad. You got 2 sections, not a whole lot of questions. Make sure you're okay for pacing. Myself and Miss Elkins will stop in to come say hello and see what questions you have as we can try and quickly answer as we run around. But you've got this, and you will be successful. Good luck, and I look forward to seeing you tomorrow and to grading these. Bye.